The presentation is about the serverless startup. It's I'm going to skip this slide because this is for you can download the presentation afterwards via the CodeMotion site. And I'm going to talk about our architecture that we started for our new founded startup. I'm going to briefly explain why we started this startup and why we chose to go serverless and which technologies we used. And then I'm going to dive into the technologies itself and try to explain them one by one to give you a bit of an image about what it is and how you can use it. So this is me. I'm Marcel Panse. I've been a freelancer for about 10 years now, worked mostly for startup companies. And at startup companies, you have this normally you start like custom-built software, right? So you start a Ruby on Rails project or Java or Node or whatever, and you build something from scratch. And then at one point, if your startup grows, then you hire marketeers and content managers, and you have people in the company that wants to like change texts and handle multi-language issues in your site. So we saw this problem at every startup I basically worked at, and there's no good solution because normally you have to integrate like a old-fashioned content management system, something like WordPress or Joomla or whatever, and developers just don't want to work with those old-fashioned systems, and you don't want to install them and maintain them. So in like September last year, we decided to just build something ourselves. We had a good idea how we want to solve this solution using a JavaScript framework in the front end and a serverless backend. We had 2 launching customers that I currently worked at, so that was perfect to just try the idea and see how it worked. But we didn't have any clue if it would generate any traction within other startups or the community. So we also didn't want to spend a lot of money on it. It's just an idea that we want to try out. And if those 2 startups were going to use it, then we should be able to keep it online forever for a very cheap cost. And we didn't want to do any maintenance on it. So it should be as low profile as possible. Then last year, Lambda and API Gateway by Amazon AWS got launched, which is some awesome new technology, and we wanted to do something with it. So we got triggered by just starting the project in the weekends and starting testing it and building it in the weekends in our spare time. So we created a simple website around it. We wrote a blog post that got published on highscalability.com. It's called The Serverless Startup. And we got a lot of traction all of a sudden. So because we now got all this traction, we thought, like, let's start a real company. And we joined Workstart Accelerator. And for the people that don't know what Workstart Accelerator is, they invest in startups in a very early stage, and they help you, guide you through the first 1,000 days of your startup life. And they invest a little bit of money, and you get a lot of help from their community of mentors and investors. So we basically started full-time working on it about 6 weeks ago. So it's still very, very young. The benefits of going, the last part, it's very secure because it's hosted, the infrastructure is hosted at Amazon, and they have this great team of very professional security experts, and they know how to keep everything secure. And they have much more expertise on the topic than I have. So I trust them to do a better job than I can do personally myself. And it's infinitely scalable, so you don't have to worry about scaling up or down. because that's handled automatically for you. Of course, there are also downsides. It's a very different way of programming. You're programming microservices. Every API call is just a function as a microservice. And it's not a big monolithic application, so you have to develop your application, and you have to with a different structure than you would normally do if you use a framework. So it's a bit harder to make complex software. It's also very new and fresh. There are already being frameworks being developed for to make it easier to build these kinds of applications, but yeah, it's still all very fresh. So it's a bit more complex than it would normally be, but in the end, it saves you a lot of time. So about the architecture, I'm going to get back to this slide at the end, because we're going to go through every single item on the slide. Just to go through it quickly, if you have a visitor on our teletext.io website, then the visitor goes to the website, and it goes to a static website that's hosted in S3, and that's served through CloudFront. Then if our website downloads any text, because we are a content management system, we host the text for you as a service. Then those texts get pulled in through another data bucket, which is also just a static S3 bucket. So if you want to edit those texts, you have to do API calls. You have to save drafts, update drafts. You have to be able to publish it. So those are all API calls. The API calls goes through the API gateway of Amazon. The API gateway is connected to a Lambda function, or a bunch of Lambda functions, which execute your code. And they use DynamoDB as storage. And there's also a connection between Lambda and S3, of course, because you have to write stuff into the S3 buckets. So let's start with the Lambda functions, because that's basically the core of the product. That's the most important part. And according to Amazon, they explain it as Lambda lets you run code without provisioning or managing servers. So you literally don't have any running instances. You just have your code. You upload your code to the Lambda function. And then Amazon will provision the service for you. So whenever an API call ends up with your Lambda function, Amazon will run this Lambda function on a Docker image on one of their servers. And you don't know which server it will run on, but it will just take something that's free. And then you actually pay per usage. So for every 100 milliseconds of usage, you will get credited for like a couple of cents or whatever. The price also depends on memory allocation. So if you have a Java project with a JVM that uses more memory, that will be more expensive than, for example, Node.js or a Python application. Lambda has a free tier, which is very generous. Normally, the free tiers in Amazon spend for only 1 year, and then it ends. In Lambda, it's indefinitely. And it's pretty big, so if you for new projects and new startups, you can basically launch for free. You don't have to pay anything until you get bigger. For our startup, we don't pay anything for Lambda yet. And Lambda works by connecting events. So if you have for example, a file is uploaded into a S3 bucket, then this generates an event in the AWS system. And everything you do in the AWS system generates an event. And you can connect that event to a Lambda function. So for example, I upload a file to a bucket. Then a Lambda function can grab that file, make a thumbnail, and put the thumbnail back. And now you have an automatic thumbnail generator. For our example, we use the API gateway. So whenever an API call gets in, it launches a Lambda function. For some code demonstration, this is just a simple hello world example in Node.js. It's basically very simple. You can load any NPM dependency, so you have to bundle the dependencies with your code. So any NPM dependency that's available, you can bundle that in your zip file that you have to upload whenever you deploy a new version of your function. You have one main function, one handler that gets an event, and that event is filled based on whatever the event is coming from. So, for example, if it comes from S3, you get some data about the bucket location, the key of the file, the size, and stuff like that. If it's an API call, you get the request body, for example. Then you can do stuff with it. You can execute your function, and whenever you're done, you call the callback, and that's the response you're responding back to whoever called your Lambda function. If you call the first parameter, then that's reserved for error messages, then automatically it will return an error message instead of a 200 OK response. So yeah, it's basically very simple. You just write your function. You make a zip file. You upload it to AWS, and it works. But the function has to be called, of course. So what we do is we use the API gateway, and the API gateway is a service that's fully managed by Amazon also, and it makes it easy for developers to create, publish, maintain, monitor, and secure APIs. Basically, it's just a point-and-click interface in Amazon where you can define your API. So you can add resources, you can add versions, you can add methods on your resources. And there you define your RESTful API. And for every method, you define which Lambda function it should call. It has a couple of features like cores, and you can add and modify any data that comes in or goes out before you call your actual functions. So you could even connect it to a legacy system where you have a different API and map that API to your old system. You can use a custom domain, and it's fully authentication supported, so you can use your IAM users to be able to define if you can call certain functions or not. What's also nice about it is it generates an SDK. So if you use it from your website, you can generate a JavaScript SDK, and that just makes it very easy for you to be able to call functions on that SDK, and that will handle all the requests and response data and parse the JSON for you and stuff like that. So you don't have to program it yourself. So this is a way to define and expose an API on your domain without using any server or framework or whatever. If you go into Amazon, it looks something like this. You have, on the left side, you have your resources, and per resource, you define your post and option calls and stuff like that. And then on the right side, you can define your request and response. Also, if you modify any headers, or in this case, it's just pass-through, so we don't modify anything. And it's connected to a Lambda function, but it could also be connected to like a legacy system, a URL, or an S3 bucket, for example. So if you have this, now you have a service, you have a function that's running, you can call it through the API, but you of course have to store data, and normally you would store your data in a RDS server or a self-managed instance with MySQL on it or some other database server. But since we don't want to use any servers, we decided to use DynamoDB, which is a NoSQL service by Amazon. It's basically a key value store. So it's super simple. It's not comparable to any relational database service. It's even compared to MongoDB. It's super simple, very crude. You cannot do much querying, but you have to define every index yourself. So when you're starting with DynamoDB, make sure to read up on DynamoDB and NoSQL service, because the biggest pitfall in this is that you really have to restructure your data to be able to use this service. And it's a different way of programming compared to traditional relationship RDBMS servers. So if you haven't done that before, make sure to do some research before you start. Performance. So Amazon, they make sure that the database responds in single-digit millisecond latency. So within 10 milliseconds, you have a response from your query. And it doesn't matter how big your data set is. So it's infinite scalable, and they always respond to your query within 10 milliseconds. So it's very consistent, and you know the performance of your system at any scale. If you, the test we did so far with this setup is that if you use the API gateway that goes through a Lambda function that gets instantiated, that runs, goes to DynamoDB, stores something, then goes back and responds back to the client browser, that takes about 300 to 600 milliseconds on average, depending on your function, of course, and what you're doing. You can do this faster if you have a dedicated server and you have some application. Then, of course, you can do the same thing very fast. But the big difference is that if you have like 100 sessions at the same time doing the same function call, then your single server will probably be very slow and everything will stack. In this case, every Lambda function is run separately on different servers. So it doesn't matter if it's one call or 1,000 calls. It will always respond between 300 and 600 milliseconds. So it's very consistent in scaling, and it's very predictable. If we serve our text through our content management system, we of course wanted to be faster than this. So what we do is we store any data that we want to be available very fast. We store that in S3 as just a flat JSON file and serve that through CloudFront. This way you can achieve millisecond latencies between 30 and 50 milliseconds. So that's also something you have to think about, how to structure your data and how you're going to save your data, if you're going to store it in the database or if you're going to cache it in something like S3. Some code example. The DynamoDB setup, the REST API of AWS is very verbose. It's a lot of code if you use it directly with the AWS client. I'm using here DynamoDB doc, which is an NPM package, which makes it much easier to update a item in your database. So as you can see, it's relatively simple. You just add the table name, you specify the attributes you want to update, the new value you have, and then you call the update item, and it's updated into the DynamoDB database. So it's pretty straightforward. If you now have this setup where you can just call the REST API, launch a Lambda function, and store your data in either DynamoDB or in S3, you, of course, need some kind of security. Because you don't want to be, it shouldn't be able for anybody to post any data to any account, right? So you have to do authentication and authorization. But we also didn't want to reinvent the wheel here, and we don't have any server. So fortunately, Amazon has this service for it called Cognito, which is actually built for mobile devices, but we only use it in web, and it's perfectly fine. And Cognito is a user sign-up and sign-in service, which makes it able to authenticate your users against Google, Facebook, Twitter, or Amazon, or any other OpenID provider. how this works is that in the website, in the client, you just authenticate, for example, against Google using the Google API. It's all client side. Google returns a ID token, and you can send this ID token to Cognito using their API. Cognito will authenticate this user against Google, checks if it's valid, and then provides temporary IAM security credentials. And you can define the role of those credentials, and you can define whatever Amazon resources this person can use. In our case, we only allowed you to use the API, but you could also allow a specific S3 bucket, for example, so that the users be able to upload to this specific bucket. It supports OpenID, and I just basically just explained this. One tip, Lambda functions, they run on different servers every time, but Amazon tries to group your functions at the same server if they are able to. So most of the times your function will execute on the same server, and you have access to this temp folder. You get like 5 GB of temp space, I think, and this temp space is available across functions. So if you, for example, check the Google authentication server side in your Lambda function, you need a certificate. You can download the certificate and store that in the temp folder. Then on the next Lambda function, the certificate is probably already there, and you don't have to download it again. But of course, you have to program it like it's not there, because it can run on different servers at any time. Lastly, if you now have your cool new service and you can call it through the API, you can store data, you have authentication, authorization, you still need like a website around it, right? So you need to show the world what you're building. So S3 has a solution set for this. Most of you probably already know it because it's like 6 years old or something. You can host static websites in S3. So you just build your website in HTML and JavaScript, and you upload it to a S3 bucket. In S3, you define the bucket as being a website, and then you can connect it to a domain, and it's served directly from S3 to your visitors, which again makes it super scalable because you don't have to think about server capacity and stuff like that. For our startup, we chose to use React. And for React, it's a little bit different because you have to compile using Webpack. You compile a static site, and then you have to upload that static site to S3. But since it's a single-page app, you don't have any routing because every URL will go to a S3 bucket to a specific path, and that won't exist because the file won't be there. You only have one main index file. Fortunately, there is a simple solution for that. You just have to use a CloudFront distribution. And in CloudFront, you can define whenever a file is not found in S3, you can define a custom response with a redirect to the correct file. So you just respond with the index HTML file instead of the whatever was requested. That loads your single-page app, and then you can use the URL again to navigate to the correct page. So to get back to the picture, we have a single-page website built in React that's been served from S3 to CloudFront, so it's distributed worldwide in the CDN network, which makes it able to be super fast at any place in the world. Same goes for our static data and the cached text. And also the API is using the API gateway and going through the Lambda functions on DynamoDB. Yeah, we have some time for Q&A. I'm not sure how much time we now have. 10 minutes? 10 minutes. So if you have a question, please raise your hand.
I have 3 minutes.
Oh, wait, sorry. Do you want to use the microphone? Or?
No, I can speak louder.
Yeah, everything is recorded, and they want to have the questions on tape.
Hello, I have two questions. How do you approach testing the Lambda functions? So unit tests. How do you do integration testing of the whole system? What about versioning and private internal NPM libraries?
Yeah. So that's 4 questions.
Yes. Okay, the first is like testing.
Yeah, testing is you can. It's just a single function in just a Node.js function. So you can write tests locally, how you would normally do, and write a unit test and test that function. So every function you deploy to Lambda, you test separately in your npm setup. So that's not different than any other system, I think.
But the context varies.
Right. Yeah. If you normally you run the Lambda functions in Amazon itself, right? But if you're developing, you can also run it locally, and you can specify a dummy event, which is just a simple JSON file, and you can specify your event data in it. And whenever you run the function locally, you will get this event passed in, and you use that as data for your function, and then test your function. If your function uses any AWS services, which usually is the case, so if you use DynamoDB or whatever, you have to be online. So using a serverless approach, a downside is you cannot develop offline. You have to be online to develop your code. For versioning, you can, if you deploy a Lambda function, a new version is being made. So every deployment has a new version, and you can make pointers to a specific function. So you can define a version to be your production version, and then new versions will be deployed on top of that, but you will still use your production version. And then at one point, you just change the label to the new version and then define that as your production version. So you can make a test version, production version, and define your environments that way. I cannot remember the other question. Yeah. The Lambda function itself doesn't download any npm stuff, because that would make the function really slow, and you want it to be as fast as possible. So whenever you develop locally and you use a deploy script, you package all the dependencies and you package them into a zip file. Then you upload the zip file to Amazon, and Amazon uses that zip file with the dependencies included. So locally, you have access to your private repository, and you just packages it all together. Yeah.
Thank you for the talk. I have a question regarding the monitoring. Are you using CloudWatch for monitoring the Lambda functions? And if yes, are you configuring the alarms for monitoring real times the API?
Yeah, I can show you. I have internet connection here, so I hope it works. So normally, if you have a monolithic application and you have some error, you just go to the server, go to the log file, you know where it is, right? In this case, you don't have a server, so you cannot access the log files. How Amazon fixes this is, what you see here is the, nothing? Empty space. Okay. So this is the Lambda setup. These are the Lambda functions. If you open a function, doesn't really matter which one, then you have a monitoring tab. This shows some basic usage of your function. So how much time it's called, the average duration of your function. So if it goes up all the time, you of course have a problem. You have to investigate. If there are any errors, so whenever there's not a valid output of your function, you will get an error. And you can also set up throttling. Also in the API itself, you can set up throttling of your, you can set up a burst limit and a usage limit per user to make sure that you don't get spammed. So whenever here's an error, you have log files in CloudWatch. So by clicking here, it opens CloudWatch. And it opens the log files. You can open a log file, and you see just the output of your functions. So everything you output in your function, it gets in these log files. And everything is gathered here in CloudWatch, where you can search it and go through your log files. It's still pretty basic, so you don't have any filtering. You cannot filter errors from info messages, for example. So those are things they still have to build. It's still fairly new. But at least it gives you access to whatever your function is doing. Yeah. So the question was, can you put alarms on the functions? I think I've set up a bunch of alarms. Some of these alarms are set up automatically by Amazon. But because everything is going to CloudWatch, you can set up alarms like you normally would do with other CloudWatch metrics. So it's just a metric. You get a lot of Lambda metrics, like average duration, latencies, that kinds of stuff. So you can set up alarms based on that. So whenever a function on average executes not within 1 second or something for at least 1 hour, then you can get an alarm, and that will send an email to your personal account, and you can investigate it. Yeah, so you can set up basically everything just like normal AWS CloudWatch metrics. Okay? Any question? The back?
Just a question. You mentioned that, for example, logging is quite basic functionality. I remember last time we tried Lambda functions a couple of months ago, we had a problem that it doesn't support security groups and make it quite hard to use it with like classic databases, RDS.
Mm-hmm.
If you have any idea if this has changed so far or still it's not there.
It doesn't support security groups. I'm not sure if that's the case still, because it returns an IAM user, right? And you can specify a role on that user,
yep.
And you can just make a policy on that role that allows you to do certain stuff. In our case, it's just a read-only API policy. So you can't do anything else. You cannot call the database or whatever. Then for the Lambda functions itself, they execute in a different role. It's not connected to the Cognito authentication. So they have access to write to DynamoDB and S3 or whatever. But it's a different role.
Yeah. Okay. Yeah. Thank you.
So yeah, I'm not sure if it's still a problem or not. I cannot tell you.
Okay. Never mind.
One question there.
It seems there are a lot of moving components that I would normally want to put under version control. Mm-hmm. For instance, you have a whole load of separate scripts that you might want to put into a Git repository. You have this API gateway configuration. There's a lot of stuff moving around. How do you actually develop this? Do you have everything locally and have a script to push everything to Amazon, or do you do everything on the live environment?
No, so if we quickly open IntelliJ. So basically the website itself is a React site, so that's in GitHub. That's just a normal website. The Lambda functions are just separate functions that you can add here. If you check out Lambda function, then there's a build file. So it's built with Grunt, but you can use any build surface. This makes it able to invoke your function locally. So when you're developing a function, you can test it. and it makes it able to deploy and package everything just from a single script. The API gateway, the configuration is just in Amazon. You don't have any local files. It's not a downloadable script or anything. So you just go to the website and configure it there. And you cannot run it locally. So you need online access, and it's managed in the cloud for you. And it's not something you run offline. You can build different environments. So you can build a test environment and a production environment and maybe a development environment. But it's a bit harder than a traditional application, because normally you would just install everything locally, run it locally, and develop locally, which makes it much easier to try out stuff. And in this case, you have to be online, you have to use the services, you have to configure that. So it's a bit harder.
I understand that you have to be online, but apparently there is some support from Amazon for doing this versioning, marking some version as a current production version, those kinds of things?
Yes. Yeah.
Okay. Thanks.
Yeah, it's both in the API gateway. You can define versions of your API. So you can make a test version and a production version. And in the Lambda functions itself, you can define multiple versions of your Lambda and point one to test and point the other one to live. So that's possible. So to conclude, it's harder to develop at first sight, but you just don't have to develop a lot of things you would normally do in your, if you have like a Spring application or whatever, you have to build a lot of things yourself and use dispatchers and services and combine them together and run it on a machine. So it saves a lot of time because you don't have to do all that stuff. That's everything is managed by these Amazon services. So setting this up for a startup which want to do some really quick prototyping and just getting it live and see how it works, this is perfect because you can get up and running in just a couple of days and have a very basic website with a service behind it.
Okay, thanks.
Okay. We're out of time. One more question.
Thank you. So you mentioned it's a good way for a startup to get something live quickly. Do you also think that at some point it makes sense to move to setup with servers? Like, would be more cost efficient maybe, or is that not the case?
No, definitely not for costs, because our startup itself, it runs with like 600 customers for something under €20 a month. It's super cheap, and that's because you don't have to have like one server up and running 24 hours a day. And because that's the biggest cost in Amazon. And if you want to use a RDS database, then you have 2 servers up and running 24/7. That's basically the minimum. Normally, you would also want to have your server be duplicated with a load balancer. So then you already have 3 at minimum servers. So that will cost you at least like €50 a month just to get started. Then if your startup gets big and you have to grow, you have to add more servers and configure that and maintain it and do a lot of DevOps, which of course costs a lot of money and time. And in this case, you don't have to do anything. It just auto-scales automatically. You don't have to do any DevOps. So it just saves programming time and maintenance time. I cannot tell you how much it will cost comparing like on a grand scale if you're really big, because we are not yet. But if you do the calculations, it should be way cheaper than the traditional way.
Okay, thank you.
Okay, then thanks all. I have a stand downstairs, so if you have any questions, I will be here today and tomorrow. You can just come by the stand and we can talk about serverless or teletext or whatever. So come visit me there so I won't be lonely all day. And I want to thank you all for coming and attending my talk.